All right, so let's suppose we're trying to do the reaction as follows. Sulfur dioxide reacts with oxygen to produce sulfur trioxide. All right. Is that balanced?
No.
No. Can we balance it?
Mm-hmm.
Sure. What are we going to do?
2 in the sulfur dioxide.
2 in front of the sulfur dioxide, 2 in front of the sulfur trioxide, excuse me. Good? Okay. Now, what we have over here on our little chart, if you look in the back of your book, is you have the delta HF naughts for all sorts of things. So what that says is to form sulfur dioxide from its elements, it produces negative 296, or it produces 296 joules per mole. All right? So that says that if we take 1 sulfur plus 1 oxygen molecule and we make sulfur dioxide, it's going to give off 296. All right? Now, it's important to notice a couple of things. I'm going to drop the units just for expediency. Actually, no. All right? Now, what if I reverse the reaction? What if I had sulfur dioxide producing sulfur and oxygen?
That's the opposite.
Then what would happen to the sign? The sign would reverse. Okay? Because think of it logically. If I put the two together and they make this and it gives off heat, if I break this up, it's going to take in heat, take in energy. Good? Okay. It's amazing how quiet everybody gets when there's a video recording. All right. Now, what if I said I was going to make 2 moles of sulfur dioxide react to make 2 moles of sulfur and 2 moles of oxygen?
Multiply by 2.
Now, here's the one careful warning. This says per mole. Now we're not per mole anymore.
Yeah.
Now it'd be 593.6 kilojoules, period. Right? Okay. Now, if you'll notice, this 2SO2 is part of the reaction we're trying to solve the energy for. We want to know how much energy that reaction over there on the left gives off. So what I'm going to do is just like we used to do with the redox stuff, I'm going to go, okay, 2SO2, I'm going to keep the arrows in the same place just so as not to confuse myself. And we're going to get positive 593.6 kilojoules. Okay? Now we've got another reaction we want to account for. Sulfur trioxide. This one would look like what? Would look like S plus, actually, S plus O2 goes to SO3. Is that balanced? No. Right? So what do we got to do? 2 and 3, what's the easiest thing? We still have to make 1 mole of this stuff. So how much O2 are we going to need? 3 halves. 3 halves of a mole. Can you have 3 halves of 1.5 moles? Sure, why not? Is that allowed? Of course it's allowed. I can do anything I want. I wrote the book. No, but I mean, is that going to work? Yeah. And then, so that says that this would give off, what, negative 395. So it's negative 395 kilojoules per mole. Right? So that's still per mole of sulfur trioxide. Okay, so if we want to use it over here, what's the only thing we have to do? It's S plus 3 halves. O2 goes to SO3, but what do we need? We don't need 1, we need how many? For the equation we're trying to solve for. We need 2. So this will be 2. 3 halves times 2 is 3. 2. And what's the del H? Multiply that by 2. So that would be negative, what, 680, 691.4 kilojoules. Good so far? Questions? Okay, yes, sir.
How'd you know to write like the equations in that way? Like why'd you
Okay.
break them apart that way?
The only reason I did that was because I said, okay, this is over here, right? I have the delta HF naughts for both of those two reactants. Okay? And I said, okay, but I need two of them, so I flipped it to put the SO2 on the correct side, and I doubled it to make it equivalent to the reaction I'm trying to solve. Now, if I go back to what I just did and add those two up, I'm going to get two S's plus three O2s plus two SO2s goes to two SO3s plus two S's plus two O2s. Cancel anything? Two S's. Two of the O2s. And does that look a lot like the reaction at the top? Now, without ever having done that reaction, can you tell me what the energy of that reaction is? It's going to be negative, I don't know. Wait, that's not 690, that's 790. Bad math, because that's 395. Apologies. So, whatever this is, can somebody do that real quickly so I actually have a number? What is it, 197? Did I do that correctly?
She had it, she looked at it, and then she put it down.
Okay.
That's embarrassing.
Okay, so what that says is that this reaction, using those two half reactions, or those two, let me say it this way, those two delta HF naughts, I can solve for this reaction and tell you what the energy of that reaction is without ever having done it. Good? You can stop that.